This handout goes through some basic information which you might be asked about integrated circuits. And so I would take your time and read through this. So integrated circuits are categorized really in three different ways. The technology in which, how they're made, actually, I should say, the technology on which the circuit is based. It's really how they're made. The package style, which we'll get into in a moment, and the scale of integration. So in this class, we've been using TTL chips, and they're made out, there's transistor logic is what TTL stands for. This is how they're constructed, bipolar junction transistors. You don't really have to know what that means. And they tend to be faster than the other type of chip, which we're not using in this class. They're not as sensitive to damage from electric discharge. They're not sensitive to static electricity, basically. The other type of chip, which we have not been using in this class, are called complementary metal oxide semiconductor chips. They're constructed differently, and they use less power than TTL chips. If you saw a chip like this, you wouldn't even notice the difference. They look the same. They're just made a little bit differently. All right, let's take a look at the next part. In this class, we are using THT chips. That stands for through-hole technology. I mean, it's kind of obvious why it's called through-hole, because they have these little pins here. They're designed to go, through a hole. Those are the kind of chips we've been using. The other type of chip which we have not been using in this class are surface mount technology chips, and you typically see those for mounting obviously on the surface of something, and they can be made much smaller than the chips we've been using, but the chips we've been using are great for prototyping. All right, let's look at the next slide. Certainly don't have to memorize this chart, but you should be familiar with some of these numbers. Like, we started out the year using these basic chips with just like 6 AND gates or OR gates or NAND gates. These are called small scale integration or small scale integrated circuits, generally less than 10 gates per chip. And then we started using flip-flops, adders and counters, multiplexers and demultiplexers. These are medium scale. That's about as far as we got in this class, except actually we did program a couple of things. We programmed, we programmed onto this board the 7-segment secret message and so forth. So those are large scale integrated circuits between 100 and 10,000 logic gates. And beyond that, of course, are things which you might find in your computer, but we have not used anything like that in this class. This last part is worth reading through on your own as well. And it says when circuits become too complex to breadboard, people typically use programmable logic devices, and we did that a couple of times in this course. The abbreviation is PLD, programmable logic device. Yeah, you get it. And they've been around for a long time. I mean, since the 70s, it says, and they're made in various ways as well. They're PALs are programmable array logic, and there's other types as well. And here are some questions which you might possibly be asked about material on this sheet. You might be asked, what is an advantage of using an integrated counter versus discrete logic gates, right? I mean, an integrated counter, we've done a couple of those, synchronous and asynchronous. Obviously, they're a lot easier to prototype. I mean, rather than building it out of basic AND and OR gates, that would take a lot more work. It's much simpler to use an integrated counter. What might be an advantage of using a programmable logic device to prototype your circuit? Well, I mean, that's obvious as well, right? You just design the circuit online and boom, you program it. And again, it's much easier, much quicker. There's less wires, there's less, if something goes wrong, you just fix it on the computer and reburn the chip. Simple as that. And finally, you might be asked some questions about the scale of integration. And we talked about that just a moment ago. Like a 2-input NAND gate chip. Well, of course, this is just 4 gates on a chip. This is a small scale integrated circuit. So as I said before, you should have some idea of what small scale or medium scale or large scale is. And that's about it.